Good morning, everybody. Welcome back after the weekend. Happy Monday. Today, our target is to identify 4 different methods to measure the amount of a substance. That's our first target. There will be a second video that will be posted that'll have a different target. So we're going to cover 2 very small topics today, and that's the plan of attack. All right. Before we start getting into our new unit, I want to take a little bit of time and just talk about some of the vocabulary that we're going to be using in this unit. So anything that I write down on my whiteboard, I want you guys to write down in your notes. So take a little bit of time, pause the video, and write down today's target as well as the 3 vocabulary definitions. And when you've done that, start the video back up again. All right, so first definition that we need to talk about is a mole. This one really tricks people up because they think of a mole as like the little fuzzy furry animal, and in science terms, that's not what it is. A mole is a number. Just like a dozen means 12, a mole means 6.02 times 10 to the 23rd representative particles. Okay, so if a mole is a number of particles, what's so special about something being a representative particle? A representative particle is just a broad category used to describe things that are really small and atom-like, but not necessarily atoms. Atoms are definitely representative particles, but things like molecules are representative particles. There's something we haven't talked about yet called a formula unit. A formula unit is basically just molecules of ionic compounds, and that is also a representative particle. And then, of course, particles are representative particles. Okay. So moles are just a bunch of really small things. Okay, well, scientists, we like to be precise. We don't like talking about things in terms of a bunch. So exactly how many is this particular bunch? Well, it happens to be something called Avogadro's number. So Avogadro's number is simply 6.02 times 10 to the 23rd, meaning 1 mole is Avogadro's number of representative particles. Avogadro's number is like the word dozen, just like 12 is to 6.02 times 10 to the 23rd. It's really just a name that represents a number. And the distinction between Avogadro's number and mole is very similar. They're basically synonyms. Cool. Okay, so now that we've learned some basic vocabulary, let's talk about today's target. We've measured a lot of different things in science class. Before I actually give you any answers, take a moment and think, what are some different ways we've measured the amount of a substance? I bet that you can think of at least 2. Try and come up with at least 2, and then we'll see what they all are. Okay. So I'm sure a lot of you probably said something along the lines of mass and volume. We can measure mass in terms of grams, and we can measure volume in terms of liters. Okay? And both of these can be used to describe how much of something is actually there. Of the 2, mass is actually defined as the amount of stuff. It's how many grams, how much stuff there is. If you have 100 grams of substance on Earth, it's still going to have the same mass in outer space. Okay. Volume kind of describes the amount of stuff. It really describes the amount of space that a certain amount of stuff takes up. The volume of a substance can change. For example, if I had 1 liter of gas on Earth and I took it into outer space and I let it spread out into outer space, that gas would take up hundreds of liters of space. So when I say that volume describes the amount of a substance, I'm being a little bit liberal with how I define the term amount. But we will be using volume in this unit, and that's why I'm talking about it now. If that didn't make any sense to you, basically understand that these are 2 ways we can measure substances. Okay. So what are 2 other different ways we can measure substances? Well, we can measure the particles, right? And that just has units of particles. We can measure effectively the atoms and the molecules and things like that. And we can also measure something called the mole. Okay. And moles, it's a little silly, but scientists, we are efficient in how we write things. So instead of writing moles out each time, I am going to abbreviate mole to MOL. These mean the exact same thing. Sometimes you'll see it written like this. This is the singular mole, this is multiple moles, and this is the unit for moles. They all mean the same thing, okay? And a mole, what's a mole? Think back to our unit, don't check your notes unless you have to. What is a mole? Yes, Avogadro's number, 6.02 times 10 to the 23rd particles. It's just a lot of particles. That's all a mole is. It's not very easy to measure the amount of a substance in particles because they're so small. It's not like we can count them exactly, but we can count bunches of particles, and that's why the mole exists. Okay, folks, so that is the first part of today's target. I'm going to briefly introduce a topic that we're going to be using a lot this week, and it's going to help us with the second topic that we'll be learning this week. So if you guys have one, you're going to want to take out a periodic table. I'll also post a periodic table on the Google Classroom page, so you can use that periodic table to help you out when we are doing things. So the last kind of vocab word that I want to talk about today is this term called molar mass. Okay. So basically this entire unit, it's all about converting one type of a unit into another unit, right? If we know how many grams of a substance do we have, how many moles do we have? If we know how many moles of a substance we have, how many grams do we have? That's what this entire unit is about. And in order to figure that out, we need these things called conversion factors. An example of a conversion factor is there's 12 inches in a foot. There's 100 centimeters in a meter. Those are conversion factors. They're ratios of two numbers that tell us how to get from one type of unit to another. Molar mass is just a conversion unit. Okay, so it's a conversion unit specifically that tells us the number of grams in a mole. Okay, so how do we calculate the molar mass? Where is it? Well, we use our periodic table. Okay, so you'll remember in the upper left-hand corner of every single element is the atomic number, and in the upper right corner is the atomic mass. So for all of these different elements, we are going to be using the atomic mass to calculate our molar mass. And that makes sense. Masses should be used to calculate masses. Okay, so I know that the atomic mass of hydrogen is 1.01. And I also know that the atomic mass of oxygen, let's call it 16. It's like 15.999. Let's just call it 16.00 because if we're rounding, it's about 16. So how can we use these atomic masses to find the molar mass of water? All right, well, what we're going to do is we're basically going to take the masses of two hydrogens, because there are two hydrogen atoms in water. So 2 times 1.01 just equals 2.02. Okay? And we've got 1 oxygen. So we've got 1 times its mass, which is 16, and 1 times 16 just equals 16. So then what we're going to do is we're going to take the mass of hydrogen, the total mass of all the hydrogen in water, and the mass of the oxygen, add it together, and that's going to give us the molar mass of H2O. The last thing that I'll mention is that it's the number of grams in a mole. So our units are going to be, here I'll write it over here so that you can see it's a little bigger, grams per mole. Grams per mole. what I would like you guys to do is to try and calculate the molar mass of CO2. Go ahead, pause this video now, try and calculate the molar mass of CO2, and once you've done that, see if you're right. All right, let's go over carbon dioxide and see if we can calculate the molar mass of carbon dioxide. So first things first, we need to use our periodic table to find the molar masses of carbon and oxygen. So carbon is a molar mass of 12.01 and oxygen has a molar mass of 16. There is one carbon atom in carbon dioxide and there are two oxygen atoms in carbon dioxide. Carbon has a molar mass of 12.01 and oxygen has a mass of 16. 1 times 12.01 equals 12.01 and 2 times 16 is 32. 12 plus 32 equals 44.01 and then our units are just grams per mole. Nice. And that's how you calculate the molar mass. Next, we're going to be going over the second target that I want to talk about today. Let's do that. Hi, folks. So, our second target that we're going to talk about today is using something known as dimensional analysis to convert the units of one substance into the units of another substance. So I mentioned that molar mass is a conversion factor. We're going to use a very common conversion factor to figure out how many inches tall we are. Okay. So in order to do this, you will need to know how tall you are in feet and inches. I am a total of 5 feet and 10 inches tall. That's how tall I am. Okay. You're right, may be different. This is intended to be used as an example problem, and then after it, we're going to have you guys calculate your height in inches using dimensional analysis, using a conversion factor. Kind of like what we'll be doing this week with molar mass. All right, so what I need to do is I need to get feet into inches. I need to figure out how many total inches I am. So in order to do that, what I'm going to do is I'm going to use a conversion factor. I know there is 12 feet. Oh shoot, sorry. I know there's 12 inches in 1 foot. There we go. Okay. So what I can do is I can use this ratio to convert feet into inches. So I've got a total of 5 feet. We're going to come back to this whole extra 10 inches bit in just a little bit, but we're going to kind of leave it alone for now. And what I'm going to do is I'm going to multiply it by my conversion factor. I'm going to multiply it by that ratio. So if we've got 5 feet and there's 1 foot in 12 inches, what I'm going to do is I'm going to multiply it by 12 inches and I'm going to divide it by 1 foot. Or we're going to just use 1 foot, same thing, right? So the reason that I'm putting 1 feet or 1 foot on the bottom is because I need my feet to cancel out. Anything divided by itself equals 1. And so feet divided by feet just equals 1. Okay. Then 5 times 12 equals 60. And then I have to include my units. The only unit I have left are inches. So I've got 60 inches. Okay, so it's 60 inches in 5 feet, but I've got to remember I do have that extra 10 inches from before. So my total height is 60 inches plus 10 inches, or a total of 70 inches. And that's basically how we use dimensional analysis. Don't worry if dimensional analysis doesn't make sense yet. We are just kind of starting this target today. We're going to be using dimensional analysis a lot this week. And so there's going to be a lot of opportunities for you to practice it. All right, cool. Go ahead, try and calculate your own height in inches. And that'll kind of be our exit slip for today. Nice. Bye, folks. Talk to you tomorrow.